Okay, here's a bolt that I designed on my own. I want to see how close these instructions from ChatGPT come to making the exact same bolt. So I'm going to follow these along, and we're going to go to metric and, of course, use millimeters for this one. The first thing you see that it says is use the XY plane, so we will follow this exactly. So the XY plane, they have over this direction. And the first thing we want us to do here is to create a circle. I thought they were going to have us do the hex head first, but it looks like we're going to do circle first of all. And since this is an M11 bolt, they're going to have 11 millimeters for the diameter of that shaft. And it says then you want to extrude it a distance of 40 millimeters. All right, I guess that's the basics of the shaft. Looks like we're going to put the hexagonal head on next. So let me orbit around here, start drawing on that surface. And let's put the hex head on there. Of course, that's located underneath the rectangle tool right here. Make sure it says 6. And then lock in here, lock up there. And let's see what size we're looking at. All right, it says we want to do 17 millimeters from here over to there. And the reason it says that is circumscribed a diameter to that. So I wonder if we do this and then we type in 17. I guess maybe it's 17 across here. Oh, it's the same thing. Okay. So it's kind of good that I left that there because I want to do something else with that circle in just a moment. So it does look like it's not fully constrained. Let's see if we can find out why. We can say show all degrees of freedom. And it looks like maybe it's just, not centered at the origin. So let me undo that and then to see if I can move the thing around. What is it that's okay, it's being allowed to rotate. So what we can do is on this one is to click probably like coincident, or I think vertical might do it. Let's see, let's try vertical constraint with this one and that one. And at least that lined it up in one direction. And now you can see on the lower right-hand side, it's fully constrained. Now let's go ahead and extrude. We're going to extrude that only a distance of 7 millimeters for the hex head on this. And we want to give it a little bit of style here. So first of all, let's change the material. The default material, let's change this to polished chrome. So there's chrome polished. It's going to give it a shiny appearance at the end. And also, it kind of describes, I think, some using fillets and things like that. But let's do some of that, but I want to do something a little bit different. So out here at the end, it says that we can put a chamfer out here. Notice you don't have to go up here to select the chamfer. You can just click right there. We're going to do a 1 millimeter chamfer. Then down in here at this intersection right there, we're going to do a fillet instead, and we're going to put a 1 millimeter right there. Let's give it a little style on top of the head. We don't often see heads that are that sharp. So we're going to use that inscribed circle method. So we're going to do a new sketch right here. And we're going to put a circle and go all the way out here to the edge. And hopefully that's fully defined. That's good. And then we're going to use the intersection tool under the extrude. So we have that shape right there, but we don't want to select extrude or cut, but we want to do intersection. And what we want to do is flare this out so it kind of takes off a little bit of the edge. So that means under the advanced properties, we can use, I'll put a 45 down here. And you can see that it gives that classic look that we see at the top of bolt heads when we do that. So I use the intersection tool, but it looked like I got rid of the shaft that was below that. I guess I should have done this one first then, but that's okay. I guess we can do them out of order or just go back and put it in play. But it does look like that operation. Let me see if I can verify that. Yeah, it looks like it just went all the way through. Maybe I can tell it not to go all the way through, but just to go up to a certain distance of, oh, hey, yeah, how about this? We go all the way through like that. Okay. Now we got the whole thing in play. Looks a lot better. So now, I guess we can put the serial number on the top of that and make it even look more realistic, but it's time for the threads, of course. And so when you go down to the threads, you could put cosmetic threads on there, but we're going to use the coil and a triangle to cut the threads. So let's face one of these planes. How about, yeah, that one right there. We'll start sketching on that one. And what we want to do is go over, yeah, I forgot to, let's see, one on this plane here. I just want to pan over like this. And I'm drawing on this plane, hopefully. And I'm going to start by having just a construction line that starts here and goes out this way. I guess I do need to make that a construction line. And then what we want to do is make a triangle that's going to perform the cut. And hopefully I can get it to line up there. And of course, we want to make these two equal. So let's do that. There's the equal constraint. And the other thing it talks about is the pitch. Now, if you look up what the definition of the pitch is, you'll see that it's the distance from from there to there. So let's go ahead and put that in place. In reality, we probably want to make it a little bit bigger if we need to have some clearance. So we'll come back and make a note on this video if we need to change that. The angle between these two should be 60 degrees for a standard thread. And let's see, what part of it is not fully defined? Thought that would be enough. Let's see if we can figure out what's not fully defined. So go like this. It says it could just kind of move it all over the place. Okay, so what that means is that we need to give this a defined length right here. I'm glad that it noticed that, or that got pointed out, because this 2 millimeters that we're going to put from the end of this, I guess I got to lock it into position. We want this point to be coincident with that point there. And you'll see why I'm putting it 2 millimeters from the end in just a moment. Looks like it's going to be time for our cut now. So let's go ahead and begin the spiral coil cut. So notice it already selected the profile as the triangle. We need to select the axis that we want to go down. And down here, you can see it's going to be the Z axis. So I'm going to select that one. And it's going the wrong direction. So let's see if we can get it to go the other way. That's much better. And I think we want the pitch and the height because we want to leave the pitch to be 1.5. I guess and there's 40 right here. So if it's not automatically filled in, you certainly want to do that. And I think that's all we really want to do. Make sure it says cut down here so that you end up getting cut threads. So not only did we notice that the chamfer here at the end will help the bolt go into the nut, but also it looks like, yeah, that plan of coming just 2 millimeters short of the end, make sure that we don't dig into the hexagonal head. So that's why I use that 2 millimeters. All right, that wasn't so bad. Now the trick is going to be to 3D print this and make sure that it's going to function well. We might have to add some more clearance in there. And the question will be, do we want to put the clearance on the bolt or the clearance on the nut? So we'll figure out what the standards are and follow that standard, of course. All right, hope this helps, and I'll see you in the next video.